The Leaning Tower of Pisa is a famous medieval building most memorable for its distinct lean due to issues during construction of a normal bell tower. The tower was likely designed by Bonanno Pizzano in Pisa, Italy, with construction starting in 1173 and ending in 1372. Due to multiple major setbacks including war and engineers rethinking their designs to combat the growing lean, this lean was clearly unintended as the tower was built to be the bell tower of the Pisa Cathedral. The first setback of the tower's construction occurred when the tower had reached 3 stories during war. Throughout this pause, the tower had developed a lean as the tower's weight was removing water from the soft soil underneath, causing leaning instability. About 100 years later, the construction resumes and removal of water from the soil beneath increased the structure's strength to prevent further lean to a degree. Although, as the lean gradually increased over time, workers began constructing the top floors vertically and with lighter materials to lessen the weight, causing further lean. The construction of the tower was paused for a war once again after 7 floors were constructed and finally continued with the start of the bell chamber in 1360. Throughout this long period of construction, 1173 to 1372, the tower leaned north and reached a maximum tilt of 5 degrees at its peak.
Later, in 1838, an architect named Alessandro de la Giraldesca created a walkway called the Catino so people could observe the foundation of the tower and walk around it. Even though this Catino caused the tower to tilt 0.25 degrees, it was proven to help in the long run by supporting the structure against leaning. Giraldesca further improved the leaning situation by creating a thick, concrete ring beneath the Catino, which reduced water inflow to the foundation, keeping it more stable. The Leaning Tower of Pisa was built from 1173 to 1372, ending with the addition of the belfry as a final touch. Builders constructed the tower using layers of stone and marble arranged in a cylindrical shape around the circular base. During construction, workers realized the tower was beginning to slant because of the unstable soil underneath. To compensate for the lean, they built one side taller than the other, which caused the tower to develop a slight visible curve. This adjustment can still be seen today because the stairs on the south side have fewer steps than the stairs on the north side. The tower was mainly built with white and gray marble from Tuscany because the material was strong, durable, and easy to carve. Builders used marble for the outer walls, columns, arches, and decorative details, while limestone was placed inside the walls because it was more affordable and easier to obtain in large amounts. To complete the structure, the bells were cast in bronze, and the foundation was built using large stone blocks to support the tower's weight.
Gravity and normal force are the main forces impacting the lean on the tower. Gravity pushes with a downward force on the tower, which increases the stress on an already uneven foundation. The main reason the tower tilts is because the soil consists of sand on one side and clay on the other, so there's an imbalance in the foundation and how it sinks. The tower was also more prone to receiving damage from earthquakes. Finally, normal force opposed gravity, but since the foundation was unstable, the tower continued to lean over the years. In the early 1990s, the tower reached an alarming tilt of 5.5 degrees, and it was close to completely tilting over. After calculations, engineers came to the conclusion that the soil could only withstand around 7% more weight before the instability of the lean caused the tower to collapse. After placing lead blocks on one side to correct the tilt as a non-permanent measure, engineers quickly searched for a solution. The engineers strategically dug under the tower at a vertical angle, which forced the slanting part to fall back into place, and the inclination was finally reduced by about 0.5 degrees. They monitored groundwater and guided it out so that the soil did not become even more uneven. The Leaning Tower of Pisa also developed leaning instability because of its soft and uneven soil as well as a shallow foundation, which allowed the tilt to grow until the forces trying to make the tower fall became stronger than the soil's ability to resist them. At that point, even a tiny increase in lean made the tower more unstable. Modern engineering reduced the tilt and restored stability. The total height of the structure is 58.4 meters, and it has a ring-shaped cross-section. The external diameter at the base is about 19.6 meters. Due to the 5-degree tilt, the top of the tower is not perfectly aligned with the base, and it is offset by about 5 meters compared to what was originally intended. The tower's center of mass is at around 23 meters above the base, and its estimated weight is about 14,500 metric tons, or 32 million pounds. The structure was built in a way that was curved, and one side was taller so that the structure would be able to hold itself up despite the tilt. While it is not completely successful in doing so, it was still able to keep the aesthetic nature of the structure by making it seem balanced. Many simple machines were also used in the construction of the tower. Pulleys were used to move and lift the incredibly heavy materials, like marble, that were needed to construct all 32 million pounds of the towers. Screws were used to strategically remove soil under the tower to allow one side to sink and the tilt to correct itself by about 0.5 degrees. While these are the major simple machines used in the tower's construction, it can be inferred that levers were used to move heavy materials and carefully place them in specific locations. Furthermore, since the people who built the tower had to cut stone, they used techniques which included splitting stone with wedges in order to get a desired shape.
In conclusion, the Leaning Tower of Pisa became famous because of an accident during construction that caused it to lean over time. Even though the soft soil and uneven building grounds created major problems, builders and engineers found ways to keep the tower standing using various civilization methods, like lead counterweights, soil removal, tar sites, and even a catino.